Hi viewers, welcome to Solar Physics YouTube channel. This is your Shahid. Please subscribe my channel and share to your friends. Now I am going to present a new question. See here, one end of a light spring of natural length d and a spring constant k fixed on a rigid wall whose one end of the spring fixed to a rigid wall at the point O and the other is fixed and the other end of the spring is fixed to a smooth ring. This is a smooth ring whose mass is m. Fixed to smooth ring of mass m. The ring can slide over a frictionless rod which is arranged at a distance as shown in figure. When the system is released from rest, when the smooth ring is released from rest, find out the speed of the ring when spring becomes horizontal. When the spring is released, when ring is released from rest and it is comes to the bottom of the rod and the spring becomes horizontal. In this case, we have to find out speed of the ring. What speed gained by the ring when the spring becomes horizontal? So as per question, spring of natural length, see right, spring of natural length means original length. Natural length is equal to T, yes, whose one end is fixed to rigid wall and another end is fixed to ring at the point A. So when we are connected at the point A, the length of the spring is elongated. So it doesn't have a original length. It has some extension length also. We have to find out here extension length. And also the ring is arranged at a height h from the bottom of the rod. Here the rod is located at a distance d from the rigid wall. So here height of ring is equal to h. We have to find out height of the ring in known term d. So from the figure, tan 37, from the figure we consider triangle OAB. Okay, from the triangle OAB, tan 37 degree is equal to opposite one h by adjacent one d. Yes, tan 37, we know that tan 37 is equal to 3 by 4 is equal to h by d. Now h is equal to height of the ring initially, whose velocity, when its velocity is 0, h is equal to 3d by 4. Now this value we can get as 3d by 4. Now this value become as how much? 3d by 4. Now we have to find out. Length of the spring. According to Pythagoras theorem, L square is equal to d square plus another side square 3d by 4 whole square. L square is equal to d square plus 9d square by 16. L square is equal to 25d square by 16. D square by 16. See, L is equal to 5d by 4. 5d by 4. This is a total length of the spring. Total length of the spring, when whose one end is connected to rigid wall and another end is connected to ring. Connected to ring along with the elongation. Total length of the ring is a 5d by 4. What is the natural length of the spring? What is natural length of the spring? D. Yes. So when we are connected spring in such a way that whose one end is fixed to rigid wall and are connected to the ring at the point A, some elongation will be takes place. So elongation of the spring, elongation of spring, elongation of spring, elongation of spring x naught, elongation of spring x naught is equal to L minus D, means extension length of the spring minus natural length of the spring. That is x naught is equal to 5d by 4 minus d, that is x naught is equal to d by 4. This is a elongation of the spring, and 3d by 4 is a height of the ring. Height of the ring. Here a question is there. We have to find out the speed of the ring when spring becomes horizontal. When spring becomes horizontal, what about the speed of the ring? When ring is comes to bottom, when the ring is comes to bottom, what happened? The spring becomes its length becomes natural length. Natural length. So to find out the speed, we have to apply law of conservation of energy. Here there is no external forces are act on the system. If there is no external forces act on the system, there is no change in total energy of the system. So what amount of total energy have the system initially? The same amount of energy have the system when it is reached to bottom. When it is ring reached to the bottom. So total energy of the system. Now we can apply law of conservation of energy. Law of conservation of energy. SELCE. Total energy initially is equal to total energy in the final state. Total energy in initial is equal to total energy in final. Initially, what is the total energy of the system? So the energy of the system is a sum of energy possessed by the spring due to elongation and energy possessed by the ring which is located at a certain height h. Yes. Now initial energy is equal to energy possessed by the spring due to elongation. Already we know that energy possessed by the spring due to elongation, that is 1 by 2 k x naught square plus energy possessed by the ring which is located at certain height. That energy is a potential energy, that is a mass of the ring, g gravity, height of the ring is equal to, that is the initial energy of the system. And when the ring comes to the bottom, it attains some velocity. Yes, due to that velocity, it possesses some kinetic energy. Okay, and when the ring comes to the bottom, the spring attains natural length. We have to find out speed of the ring when spring becomes horizontal. When spring becomes horizontal, it attains natural length. When it attains natural length, it doesn't possess any energy due to the elongation. There is no elongation, there is no spring energy. So energy due to the spring is 0 plus energy due to the ring, that is convert into kinetic energy of mv square. That is of k x naught value you can get elongation, that is d by 4. X naught square means d square by 16 plus mg. Height of the ring, that is a 3d by 4. Height you can substitute 3d by 4 is equal to half mv square. Half mv square. Yes. See here, half is cancelled and this 4 is cancelled. Only 2 is there and 1 by 2 is a cancel. Now equation become kd square by 16 plus 3mg d by 2 is equal to mv square. Yes. Now you shifted the m to left hand side, hence it become as kd square by 16m plus by m cancel, that's why 3g d by 2. 3g d by 2 is equal to v square. Yeah. Now you get the common. So now you get the common of d square. Now you get the common of d square. When you get the common of d square, it becomes as a k by 16m plus, see, when we get the common of d square, here only d is there, so that's why 3g by 2d is equal to v square. Now we have to find out speed of the ring, that is a v value, that is a v is equal to, so under root d square and root is cancelled, hence a d under root of 3g by 2d plus k by 16m. So this is the expression for speed of the ring when spring becomes horizontal. So v is equal to d under root of 3g by 2d plus k by 16m.